What if I told you that by just typing a few characters into a login box, you could break into almost any website without knowing the password? That's not hacking from movies. That's SQL injection, and it's real, it's simple, and it has leaked billions of records worldwide. Today, I'm going to show you exactly how it works and how to stop it. Let's go. Before we understand the attack, let's understand what SQL is. SQL, Structured Query Language, is how websites talk to their databases. When you log into a website, behind the scenes, the site is running a query, a question to the database. Something like, "Hey database, do you have a user with this username and this password?" In code, that looks like this. Select all from users where username equals John and password equals 1234. If the database says yes, you're in. Simple, right? Now, here's where it gets dangerous. Imagine a login form. You have two fields, username and password. A normal user types their username, but a hacker types this, or 1 equals 1. Looks weird, right? Let me show you what happens. The website takes that input and plugs it directly into the SQL query like this. Select all from users where username equals empty or 1 equals 1 and password equals empty. Now, look at this carefully. 1 equals 1. Is that true? Always. 1 always equals 1. So the database goes, yep, this condition is true, and logs the hacker in. No password, no account, just a few characters. That is SQL injection. Now, you might think, okay, login bypass, not a big deal, but SQL injection goes way further. Hackers can use it to steal entire databases, every username, email, password, credit card number. Delete data. Imagine someone runs drop table users. Your entire user base gone. Bypass admin panels. Get full control of a website. In some cases, even control the server itself. And this isn't theoretical. Yahoo, 2012, 450 million accounts leaked via SQL injection. Sony PlayStation Network hacked using SQLI, 77 million users affected. Heartland Payment Systems, 130 million credit cards stolen. This single vulnerability has caused billions of dollars in damage. Now, let me quickly walk you through the main types. Don't worry, I'll keep it simple. Type 1, Classic Injection. The hacker gets the results directly on screen, like the login example we just saw. Type 2, Blind Injection. The website doesn't show any data, but the hacker asks yes/no questions, like, does the first letter of the admin password start with A? If the page behaves differently, they get their answer. Slow, but effective. Type 3, Time-Based Injection. The hacker injects a command like sleep 5. If the website pauses for 5 seconds, the injection worked. They use timing to extract information. Type 4, Out of band. The data gets sent to the hacker's own server through DNS or HTTP. More advanced, but very hard to detect. Okay, so how do we stop this? The good news, SQL injection is completely preventable. Here's how. Fix 1. Parameterized queries. Most important. Instead of plugging user input directly into the query, you separate the data from the code. Bad way, query equals select all from users where username equals plus username plus. Safe way, Python cursor.execute select all from users where username equals username. Now, even if someone types or 1 equals 1, the database treats it as plain text, not as code. Attack blocked. A parameterized is simply a placeholder, a blank slot that says, I don't have the real value yet, it will be filled in later. You already know this from math. F of x equals x plus 5. Here, x is a parameter, it's a placeholder, you pass the real value later. Same idea in SQL. The bad way, string concatenation. Username equals John, query equals select all from users where username equals plus username plus. What Python does here is build one big string by gluing pieces together. Select all from users where username equals plus John plus equals. Final result sent to the database, select all from users where username equals John. The problem, the SQL and the data are mixed together into one string. The database receives it as one blob of text and has no idea where the SQL ends and the user's data begins. So when a hacker types or 1 equals 1 as the username, Python query equals select all from users where username equals or 1 equals 1 plus equals. The database gets select all from users where username equals empty or 1 equals 1 equals empty. It reads the hacker's input as SQL code because it was just glued in as text. The database cannot tell the difference. The safe way, parameterized, cursor.execute, select all from users where username equals username, comma. Now, let's break this line into two distinct parts. Part 1, the template or structure. Select all from users where username equals The question mark is the parameter, a placeholder, that says real value goes here. This is the fixed SQL structure. It is sent to the database first and separately. Part 2, the data. Username, user. This is the actual value sent to the database separately after the structure. What actually happens inside, step by step? Step 1, Python sends the template to the database. Select all from users where username equals Database reads this and thinks, okay, I understand this query. It selects users by username. I'm ready. Send me the value. Step 2, Python sends the data separately. John. Step 3, database fills the question mark slot with John and executes it safely. The key point, by the time the data arrives, the database has already understood the SQL structure. It is no longer reading anything as code. It only treats the incoming value as pure data. Now let's see why the attack fails. Hacker types or 1 equals 1. Bad way, vulnerable. Python query equals select all from users where username equals or 1 equals 1 plus equals. Database receives one mixed string, reads OR as SQL command. Attack works for the hacker. Safe way, parameterized, Python cursor.execute, select all from users where username equals or 1 equals 1, comma. Database receives template, select all from users where username equals data, or 1 equals 1 equals. The database literally searches for a user whose username is the exact string, or 1 equals 1. The quotes, the or, everything is treated as name, not as SQL. No user has that username, so it returns nothing. Attack completely fails. One simple analogy. Think of a printed form versus a blank letter. Bad way is like writing a letter from scratch every time. Please give access to John. Someone can sneak in and change it to please give access to John or everyone. Parameterized query is like a printed official form with blank boxes. Grant access to blank. The structure is fixed and printed. You only fill in the box. Even if someone writes John or everyone in the box, it's just text in a box. The form's meaning cannot be changed. One simple line summary? In a parameterized query, the SQL structure and the user data travel to the database separately, so the database always knows what is a command and what is just data. The data can never become code. That's the entire concept. The word parameterized just means using placeholders instead of directly inserting values. Fix 2. Use an ORM. Frameworks like Django, SQL Alchemy, or Hibernate handle all this automatically. They never let raw input touch your SQL. Fix 3. Input validation. If a field only needs a name, only allow letters. If it needs a number, only allow digits. Reject anything suspicious before it even reaches the database. Fix 4. Least privilege. Your database user should only have the permissions it needs. If your app only reads data, don't give it delete or drop permissions. Limit the damage if an attack does happen. Fix 5. Web Application Web Firewall. A WAF sits in front of your website and automatically blocks common attack patterns, including SQL injection. So let's recap. SQL injection works because websites trust user input and plug it directly into database queries. Hackers exploit that trust to bypass logins, steal data, and destroy databases. And the fix? Parameterized queries. It's that simple.